Hi, this is Nancy L.T. Hamilton. This video is on drill bits. I'm going to talk about measuring them, their anatomy a little bit. Also, I want to talk about drilling with them. People in classes, especially newcomers to the craft, have a very difficult time drilling into these harder metals like brass and bronze. So I'm going to show you how I drill. And I'm also going to show you 3 methods for fitting your wire into a hole for a tight fit. And I'll talk about the relationship between wire and available drill bit sizes too. So let's get started. Shall we start with a little anatomy? So let's have a little anatomy lesson on the drill bit. Right here we've got the point. This is the cutting end of it. It cuts a round hole. This is the shank down here, and this is the part that fits into your holding device, whether it be a drill press or a flex shaft. And then this is the body here. These grooved indents here are called flutes, and they facilitate the lubricant. They allow the lubricant to flow down through the drill, keeping the entire drill cool, which is one of your goals, because if you don't keep it cool, it can overheat. And if it overheats, it becomes annealed and softened. It can also damage the material that you're working on. If it gets too hot, you can burn your wood if you're cutting wood, or melt your plastic if you're cutting plastic. Here we are up close and personal with the tip of a drill bit. I'm going to try to point. I've got about a 1/4 inch gap to get my pointer in here. See this top part here? This is what grabs onto the material, and that's called the chisel edge. Then we have our cutting lips, and over here you can see the flutes where it's cut. This area here, and it also wraps around the outside in a spiral. Above the flutes is the land. See, this part is called the heel, and there is a slightly raised area here on both sides, and that's called the margin. And when you measure from this margin to the margin on the other side, over there. You can kind of see how it's a little more pointed out. Okay, so that's the anatomy class for today. There'll be a test at 3. So here's some of the drill bits. First I sorted out my burrs from my bits, and I printed out my chart online. I'll have a link in the description for you. Now I'm going to discuss how to read this twist drill gauge. I just want to mention that another one that would be handy for jewelers to have would be the twist drill gauge for sizes 61 to 80. I'll see if I can find a link. These come in, there's like 7 to 8, 9 different kinds. But they make fractional gauges, they make letter size gauges, and they make metric and numbered. Anyway, there's a lot of gauges. This is kind of like the mid-range here. I need to pick up a smaller twist drill gauge so I don't have to do what I'm going to show you in the second part of this video, or the second part of this section in this video. So anyway, what we're doing here is, first off, I colored in with a Sharpie and then sanded it off because this is so difficult to read these tiny numbers here. Since I don't usually work in this size, I don't care that much. So what you want to do is find your drill, the hole that's closest to the, so that's kind of loose. So you want to check the one above it. It's still too loose. That feels like a good fit, but I'm going to check one more. Nope. Oops. There it goes. It's my magnetic floor. Ah. So what was that, a 52? Yeah. So we've got, you know, it's not like skin tight in there, but some of the drills might fit pretty tight in there. You don't want them to be like this though, you know, where it's just flopping around. That's obviously keep going up on that. So that's how to use this. I mean, and it's pretty tough. And reading it, there's 6 billion numbers on here. But basically, this number right here on the right side is the drill size. So this would be a 52 drill. This is the size in hundredths, 0.063 hundredths, which well, I don't care about because I use metric. So I have to convert everything using my drill bit chart. So that's how to use that. And it's different from using the BNS gauge, which shows wire and sheet metal gauge, because with this gauge you're looking for the first thing that it doesn't fit into. So like fits into a 10 here, so the 11, this would be an 11 gauge shank. So that's that. If you do not have sufficient gauges, like if you had a drill bit that was smaller than a 60, somewhere between 61 and 80, you can use your calipers to measure. Remember, the diameter is measured by margin to margin on here, which are the widest parts. So I'm going to put that into my, the tip into my calipers and observe the numbers on it. And then I'm going to turn it to the left and the right, and I'm going to see if it goes any higher, all the while trying to keep even pressure on the dial. Which I just slipped everything out of there. Let's try that again. So it looks like 1.58, 1.59. I like to try to see if I can find that number again. There it is. So I'm going to say this is a 1.59. Then I go to my chart, and the closest to a 1.59 is this, and as my calipers are not right on, this is close enough. This would be a 1/16 inch drill bit. So yeah, so now we know what size it is, and we know what size it's closest to for what gauge. So if I was looking at this 1.628, this would, well, I probably wouldn't use this. I'd probably use this. This would be, the 52 would be better fit for slightly smaller. You know, if I wanted the hole slightly smaller than my wire, this one would be a bit smaller. But you never know when you'll need it that size. So anyway, that's how to use the gauges, the calipers, and the chart in conjunction with one another. When you're trying to drill a hole, the first thing you have to determine is that hole needs to fit whatever is going into it tightly. Most cases, almost all cases, it's wire or tubing. With riveting, you definitely want to have a nice tight fit so that if you turn it upside down, the wire doesn't fall out. The problem with some of these gauges, like 18, is there's so many choices, or 16, there aren't any that are exactly or close enough to the drill bit size. So like with 14 gauge, you've got available drill bit number 52 that's 1.61, and the gauge is 1.62. This is great. This is so close in size, and due to our human inability to hold still, we tend to make these holes a little bigger anyway. So this is a great fit. You want to see it slightly smaller. But when you get up to 16 gauge, wherever it went, you got a 1.291 on that. These two here are both too large. For me, I don't have the 3/64ths, which I probably should get because that's probably the closest in size. And then the next one is the number 56 of 1.18. So I have to use a drill bit that's rather substantially smaller in size, which means that the hole has to be enlarged to fit the wire, or the wire has to be reduced to fit in the hole. I'm going to just show you the way that I have found works best for me for drilling a hole in brass or bronze, which is a pretty hard material. So I'm going to be loading up my number 56 drill bit. I have already made a dent here, or a divot with a punch. The trick to drilling through this harder material is to use a lot of lubrication and to go slowly with your flex shaft and do it in several steps. If you just try to power through it, you'll end up with a big bulge in the back and a dull bit. So I'm pushing gently. You can see material is being removed. I'm going to go lubricate again. Now listen to my flex shaft. This is really fast, which I hear all the time in the studio classes. And anytime you hear it, I go running over, no, stop! Drive everybody nuts. So I re-lubricated, pushing gently. Give it a second or two. Not there yet, go back and lubricate. Give it a chance to cool off. Go back in again. There we go. We have hardly any stuff on the back. There's a word, but you know how my brain works. At least those of you who have been here before. So somewhere around here is my wire. There it is. Now this will not fit in here. It's just way too big for the hole, so we need to find ways to reduce the diameter of the wire or make the hole bigger. So I'm going to show you one way to do it, which is not my favorite because it's difficult to control, and I've seen many people overcut the hole. So I'm going to get that ready. Once again, I lubricated my bit, and this is the way most people do it, is they put it in and they kind of gently wiggle, and I've done this before myself. Wiggle it around in the hole to try to open it up. You could see the flexing of the bit there as I pushed it against the walls of the hole. Okay, so I have a good fit here this time, and I was lucky. I'm gonna drill a couple more holes so I can show you. Actually, I think I can use these. I'll show you the other two methods that you could try. I've loaded a bit of my wire into my flex shaft, and then I can take it along the edge of a file. You need to move it, otherwise it won't work. And kind of try to take off an even amount, and then check your fit. This could have a little more taken off. So you just keep checking your fit, and there we have a good fit on that. Then my last method, if the hole is slightly too small, you can come in with a minute escapement file like this, and really fine tip, so it'll fit into a lot of the holes. And I would use like a rougher cut, like a number 3, to try to open these up. Flip it to the back. I gotta keep track of which hole this is. Work the file around. I'm pushing against it in like a circular fashion, so I'm hitting all the walls. And then check your fit. Also, a lot of times when we clip these, we get burrs on the end of them, so taking those burrs off sometimes is all that needs to be done. Just make sure that I don't have any here. Oh, this one needs to be worked. It's almost there though. I can actually see it staying in, so a couple more swipes with my round nose escapement file will probably have that working. So those are my methods for working with your drill bits and opening up holes. And I'm going to shut up. Glad you could join me. Bye.